All right, you guys, chapter 3 and 4, very beginning of the packet, we are going to be talking today about a really important vocab word that we're going to start using for the rest of the semester here, and that word is called radian. And so, as you know, we've done everything unit circles so far in degrees. And if you've ever fumbled around in your graphing calculator or some scientific calculators, sometimes if you're doing anything with sine, cos, and tan and you get the wrong answer, your teacher maybe have said like, oh, let me check the mode. There's this thing called radian mode versus degree mode. So architecture, engineering, anything that uses math beyond trigonometry and pre-calculus uses this thing called radians instead of degrees. It's a different kind of unit of measurement, and it has to do with all these trig functions. And what we're going to be talking about is how to convert between degrees and radians. It's just like learning a different language. Like, you know how English and Spanish, you can say the same stuff, but it sounds totally different and reads totally different. So it's a conversion that we're going to be learning how to do. Here's the definition of a radian. It's not going to make much sense until we start talking about it, but what you need to know is that we have 360 degrees is equal to 2 pi radians. So I want to first talk about why that is. Have you ever seen this formula before? Circumference equals 2 pi r. You've learned that in geometry class 2 or 3 years ago for some of you. Did you also remember that when we're talking about unit circle stuff, the radius of the circle is, what's the radius on the unit circle? It's 1, right? So that means circumference equals 2 pi times 1, which means the circumference of the circle is equal to 2 pi. So aka 360 degrees around the circle, the same thing as their circumference, equals 2 pi radians. So what that means is, instead of doing our 0 degrees here, 90 degrees here, 180, 270, 360, this is 0 radians. Or if you go all the way around the circle, it's also 2 pi radians, because 2 pi is the same thing as 360 degrees. So that's our conversion, our switching languages that we're going to be starting to talk about. 360 degrees in radian language is equal to 2 pi. So therefore, what would half the circle be? So if the whole circle is 2 pi, do you agree that half the circle would be just 1 pi? Same thing as 180 degrees. So if you go halfway around the circle, we're at pi. What would just this tick mark be, or not tick mark, what would this degree measure be? In 90 degrees, it is the same thing as, well, okay, if a whole circle is 2 pi, if half the circle is 1 pi, a quarter of the circle would be this thing called pi over 2, or 1/2 pi. And so that means that each 90 degrees is equal to pi over 2. There's another pi over 2. This one makes 3 pi over 2, which is the same thing as 1/2 pi. And then all the way around the circle again is 2 pi. So this is the way I'm going to be labeling my quadrants now, my quadrantal angles. Instead of degrees, I'm going to be using radians. And just remember that it all comes from the circumference equaling 2 pi r, but the radius is 1. So how do you convert between degrees and radians? There is a small formula. If you're given degrees, you just multiply by pi over 180. If you're given radians, to undo that, you multiply by, you just flip that, 180 over pi. So those are our two little mini formulas. So in order to convert these from degrees to radians, 45 degrees times pi over 180 is how we convert it from the degree language that we're all familiar and comfortable with to radian language. All we have to do is reduce this fraction. So don't use like decimals and stuff. We're going to leave these as fractions. But my conversion rate, or my conversion factor that I'm using, is right here. It's take the degrees, which is 45 degrees, and multiply by pi over 180. That actually reduces to 1/4. So I'm going to leave it as pi over 4, or 1/4 pi. So let's convert this one. This one is a decimal, but I'm still going to do the same exact thing. Multiply by pi over 180 because it's in degrees. And to convert it from degrees to radians, you multiply by pi over 180. And in this case, since this is a decimal, you've probably seen this, like remember when you were in Algebra 2, if the question starts with decimals, then it's okay to leave it as decimals. So I'm going to use 3.14, or a lot of you have a pi button in your calculator. You can use that in this case so that I can leave everything in terms of decimals. So when I do 249.8 times pi over 180 and use 3.14 or use the pi button in your calculator, you can get a decimal answer. 4.3598, and this is radians. So we've converted from degrees to radians, exactly like English to Spanish or German or Chinese or French or whatever language you're taking. How do you convert back? So if you're given radians, hint, radians usually have a pi in them. How to get the radians away and turn it back into degrees is you take the radians and multiply by 180 over pi. The way you can kind of remember that is that if you have a pi in your fraction here, that means that it's in radians, and you want to cancel the pi to get it back into degree mode. So therefore the pi should go on the bottom. So if you want to cancel the pi, my pi's cancel, and again I can reduce the fraction here, so this changes to 45, gives me 405 degrees. And so when the pi's cancel, that means that you have a degree in your answer. And then same thing for letter B that we did as the earlier letter B. This one is a decimal already, so I'm going to use the pi button or 3.14 in my calculator in order to keep it in decimals. So in your calculator, you're just typing 4.25 times 180 divided by, either hit the pi button or put 3.14. And it gives you a decimal, 243.51 degrees. And that's how to convert back and forth. So it's a really, really simple little mini formula thing. If you're given degrees, multiply by pi over 180. If you're given radians, multiply by 180 over pi. And so do you think that we could convert this entire unit circle, which is all in degrees, could we convert them all to radians using that formula? Remember, you just multiply by pi over 180. So I can do the 4 quadrants first. I know that this is 0 radians, and it's also 2 pi radians if you go all the way around. That's the same thing as 0 and ending at 360 degrees. Remember that this one was pi, because it was 2 pi all the way around the circle. So if you just go halfway around the circle, it's just pi. Remember that this one up here was pi over 2, and this one down here was 3 pi over 2. But what if I needed to convert all of these? So let's start with like the 30 degrees. Remember how to convert. You multiply by pi over 180, and this reduces to pi over 6. So 30 degrees is the same exact thing in radian language as pi over 6. Can do another one. Multiply by pi over 180. I believe we did this one above. 45 and 180 reduces to pi over 4. And you can work your way all the way around the unit circle and convert any of them. I am going to pause the video and just write them all in so that you can copy them down. Prepare for something to look really crazy, because I know radians, it looks like a totally different language, but if you have ever Google imaged the unit circle, you probably saw all of these and were like, what the? That is what we're talking about today. All right, here we go, you guys. I told you, prepare for it to look really freaky. Here are all of the degree measures on the unit circle converted into radians. So remember, all you have to do is multiply by pi over 180 and reduce the fraction to all of the degree measures, and here's what they are. Yes, it looks really crazy. Yes, you're going to have this memorized, and you'll eventually get it memorized, I promise, if you keep doing the work and hanging with me. But what I want to draw your attention to is there are some patterns. Maybe some of you have already picked up on some of these, but let's look at all of these 45-degree reference angles. So let's look at the 45 degrees here. Let's look at the 45-degree reference angle in the second quadrant, the 45-degree reference angle in the third quadrant. Remember what I mean by reference angle, by the way. I mean this. That's 45 degrees. That's 45 degrees. There's 45 degrees. There's 45 degrees. So all of those 45-degree reference angles, what do they all have in the denominator? They have a 4. Interesting. Yes, that's true for all the 45-degree reference angles. What about all of the 30-degree reference angles? So here's 30 degrees away from the x-axis. Here's 30 degrees away from the x-axis, and this one and this one. Look, they all have 6s. That's weird. Let's do another one. What about the 60-degree reference angle? Pi over 3, something else over 3, over 3, over 3. There are patterns that I want you to start thinking about. In the first quadrant, all of the numerators all just have a 1 in them. That's for the first quadrant. In the second quadrant, I know what you were hoping, they all have a 2 in them. They don't. But notice that 2/3, 3/4, 5/6, those are all approaching 1 pi. 2/3, 3/4, 5/6, those fractions are getting closer and closer and closer to 1. And remember how this line right here, 180 degrees, that is 1 pi. That's one way that you can start to think about it. These fractions don't reduce either, so that should help you kind of figure out which fraction goes where. Let's look at these three. 7 pi over 6, so 7/6, 5/4, 4/3, those are all a little bit bigger than 1 because we have passed 1 pi and we're getting closer to 2 pi now, so just keep that in mind. These are all 7/6, 5/4, 4/3, those are all a little bit bigger than 1. And then how about this last quadrant here? 5/3, 7/4, 11/6, those numbers are all getting close to 2. So 5 over 3 is approaching 6 over 3. 7 over 4 is approaching 8 over 4. 11 over 6 is approaching 12 over 6. Those are all getting really close to 2 pi, which finishes the circle. Yes, I went really fast, and yeah, your brains are probably about to explode. That's okay. This is something that will not completely sink in until we keep talking about it day after day after day, keep working on homework, keep practicing unit circle questions. What I want you to know now is that I want you to make the connection of all the denominators in all the same reference angle positions, okay? These are over 4, and then we have the 3's as well. Just keep that in mind. What's interesting is that the 60-degree reference angle is over 3, and the 30-degree reference angle is over 6. Just keep that in mind. But let's actually do a couple practice problems so we can see how this is useful. Tangent of 2 pi over 3. So what I'm going to do, you do not have to convert this back to degrees. I want you to start thinking about it in terms of radians. So let's try and find 2 pi over 3. 2 pi over 3 is right here. And if you have your own unit circle, what you may have written out already is, remember we wrote all of those tangents in red? This one is -√3. And remember that that reason for that is because this ordered pair is -1/2 √3 over 2, this one right here. And so if you take the y divided by the x, you get this, -√3. So we've already done the tangent at 120 degrees. It is the same exact question as turning it into radian language, tangent of 2 pi over 3. So I get -√3. Let's do sine of 3 pi over 2. Oh, here's 3 pi over 2. It's the same exact question as sine of 270. Do you remember that ordered pair is 0, -1? So when you do y over r, you get -1 over 1, which is -1. Okay, so same exact thing, just different language. 5 pi over 3, the cosine of 5 pi over 3. Here's 5 pi over 3. Remember that the cosine is asking you for the x value. The ordered pair at this position right here is 1/2 -√3 over 2. The x value is 1/2. So that's the way that we're going to be attacking these unit circle questions from now on. I don't want you to convert all of these to degrees. I want you to just find it on your unit circle and go ahead and just apply the same rules that we've been using this whole semester so far. So tangent 3 pi over 4. Here's 3 pi over 4. The tangent there, the x and the y are the exact same. One of them is positive, one of them is negative. Therefore, our tangent is -1. Secant 2 pi over 3. So we've got 2 more here to do. 2 pi over 3 is right here. The secant is the x value flipped because it's the cosine flipped. It's the reciprocal. So I'm going to go -2. These questions are supposed to be really quick once you get the hang of doing these unit circle problems. These are very, very quick ones. Fun fact, when we are in class, actually, you guys in seats and stuff, like last year, we used to give a unit circle little pop quiz every single day of this chapter. It would be all questions that look like this. We would do 10 of them every single day, and we would give you about 5 minutes to do them. And you just breeze through them and write them and bring them up to me, and then we move on with class. So just be thinking about things like that. Here's 11 pi over 6. The question is cosecant, so that is the y value. The y value here is -1/2, but it is flipped because it's cosecant and not sine. Those are reciprocal, so I'm going to go -2. So I think I am going to pause there, you guys. That was kind of a lot of info, I know. This is a brand new language, you guys. You just learned a brand new language in trigonometry class all in one day. I'm going to save these examples to talk about in class tomorrow, these down here and the rest of the next page. It'll take us maybe 5 or 10 minutes to continue having this discussion. What I think that would be the best idea for you now is this unit circle. I think maybe you should have a unit circle handy. Like when we're in class, I usually give a blank unit circle to my students on a piece of bright colored cardstock. And every time we learn something new about the unit circle, we update our piece of cardstock and we just keep everything on there. So if you want to maybe have the ability to print out a blank unit circle, on that unit circle, you probably don't need the degree numbers anymore because you probably already know where all of those degrees fall. But maybe it would be a good idea to put all of these ordered pairs on there, and then maybe all of the radian measures as well. This is something that you can kind of have out on your desk while we're working on stuff in our Zoom class, and while you're working on homework and while you're doing group work and stuff like that. It would be a good idea. Put all of the tangents on your unit circle as well. There should probably be one spot instead of like every couple days of notes having a different unit circle. There should probably be one place that you're always putting all of your unit circle information on. What I want you to kind of focus on now is I want you to see if you can start remembering these patterns of all of these fractions as they work their way around the unit circle. So these four, the four quadrantal angles, those should make sense to you already, because knowing that 0 and 2 pi, you should be able to divide that into 4 sections. But all of these colored ones here, I want you to start thinking about and see if you can start memorizing them. Just print a blank unit circle or snapshot a blank unit circle into a notability page and see if you can just label all the radian measures. Remember, if you forget, you can always convert, but I don't want you to have to convert every single degree every single time. I want you to start being comfortable and familiar with talking about radians. That is the language we're going to be using moving forward. Okay, so pausing for there, we're going to do some more practice in class tomorrow, and let's see, we'll answer all your questions and we'll just get better and better at this every day, okay? Thank you guys for watching. Have a great night.